this one? Yeah, okay. Tingnan okay na siguro. Yun. Okay. Goods naman. Like goods. Okay, so ano ba tayo? Ay, may questions pa pala ako answer dito. Okay, API layer misses authentication logic business layer. You put architecture inside an API layer. Q1 is it's a service oriented architecture because the API layer also has the logic authentication. Because the API did not only act as a routing layer, it also acts the processing unit for authentication, orchestration, and business rules, which should be done by its own respective services. Okay, sidecar trade-off. Put logging plus monitoring inside each service. What problem appears at scale? I think sa sidecar trade-off nito, ayan natin. Ang nakita ko ng trade-offs dito is they have different monitoring patterns, like parang let's say logging patterns. Question? What the question again? Why not just put logging and monitoring in each service? Ito yun yung nakita ko path, yung pagkakaroon ng parang standard way of monitoring and logging. What problems appears at scale? problem is each team will have its own monitoring and logging standards, which is different from other teams. So operational. Uh, every services will have different. Okay, the problem is each team has different monitoring. Each services will have different monitoring and logging. So there will be in operational side upgrading there's when someone upgrades, each team should also follows. Ayaw ko. Service mesh radio check. With services mesh overkill, it depends actually. Service mesh is overkill if there are only few services. Service mesh complexity in the architecture. Medyo mahirap na explain It's kind of hard to explain. Shared logging is okay. Yan mo dun sa part na yan I got caught off guard. Well, kasi sa database, yung domain ko, it's kind of more of, it's kind of defeats the microservices approach. Well, this one is more on operational. Grabe, ang hirap niya magtanong, no? Tapos minsan parang wala rin sa book at wala rin doon sa binibigay niya summary. Wala nga lang sagot niya. You have, okay, question pa na tayo. Susunugin na naman ako nito ni ChatGPT. Each team implement its own retry logic, use different logging format, design solution using ito hindi ko masagot implement its own retry logic. Okay, you have 50 microservices. Each team implement its own retry logic, uses different logging format. Okay, so implements its own retry logic, uses design a solution using concepts here. Okay. So, I guess this one, meron tong most likely magkakaroon to ng isang services that will do the retry logic. Ito sidecar approach. Okay, retry logic. May binangkat pa siya. Ito kasi more on operational coupling tayo. Itong part na to. Balik ako sa thinking ng developer. Dito yung service mesh, no? Saan dito yung retries? So meaning I need to introduce a service mesh. And then okay. So solution dito is create a sidecar pattern approach and also the service mesh. Sabi ko kasi sa libro, medyo super summarize kasi itong binigay na ChatGPT. Resilience complex learning curve. hirap ang tanong niya. Parang wala akong mailabas na explanation sa utak ko na okay. Shit. I think hindi ko answeran to. Hindi, I need to answer this. Hanapin ko lang yung oh no. Wait na, mamaya ako after stream. Nakalimutan kong bayaran yung aking extension plan ko. Bullying ang couple of primary reference so and exploitation. Kasi masyadong mababaw yung sabuk. Nung nag-gets ko naman siya, parang merong services din na nag-handle nung let's say monitoring, yung mga tools, services din siya. Tapos parang each services parang meron silang interfaces. Sa interfaces na yun, nagko-communicate naman dun sa service na yun for, let's say, for logging, observability, gano'n. Sir, the sidecar pattern means deploying a helper process alongside a service instance so the helper handle a cross-cutting concern without changing the service business code. In Kubernetes terms, a sidecar is a secondary container that runs into the main application container in the same pod and extends or enhances the primary app with capabilities like logging, monitoring, and security. Okay. Now, Cordia, think of one service instance as having two parts. Main container, your business logic, sidecar, operational logic. Yeah, tama to. So they deploy together and live together. The sidecar is there, so your service does not need to directly implement every infrastructure concern itself. Yan, dito siya. Parang let's say may Grafana ka and then Prometheus. So they will be in a separate service. Tapos parang you will just create an interface in each services. Let's say magbibigay ng API request, magsasend ng API request to the Grafana gano'n, or Prometheus. So yun yung pagkakagets ko dito sa sidecar pattern approach. Sidecar runs next to the application instance, usually on the same boundary, and in Kubernetes, tama ba banggit pronunciation ko? The same pod that gives its tight proximity and that its share life cycle and resource with the app. Kubernetes notes that sidecar runs with the main application container in the same pod upod. Because it's co-located, the sidecar usually access local, okay. that makes ideal for intercepting traffic, collecting logs, or watching files. Separation of concerns. Okay. Dito tayo. Dinaya ako. Actually, di mo ako nagdaya. Parang nag-research ako to have more knowledge dito sa kasi in orchestration. Medyo mahirap yung part na to. Sa pag API layer, medyo mahirap yung part sa retry logic eh. Sir, ano yung magiging, ano yung role ng retry logic sa service mesh? Service mesh is an infrastructure layer that manages service to service. So parang ano na din pala siya talaga. Orchestration. Paano siya orchestration, no? Orchestration layer siya. Okay, parang medyo malapit na yung sagot ko. Kasi parang orchestration siya, no? Pero try nga natin. Pero hindi pala. Mali pa rin pala ako. Orchestration kasi is more of ano siya parang yung order, parang workflow based siya. In the try, it doesn't need to be a workflow based. So, ano tawag doon sa service? Service mesh talaga yung tawag doon, no? Okay, pwede na to. Salamat. ChatGPT ulit. Ano kaya? Pero feeling ko it's not good enough. Yeah, sabi na it's not good enough. Again. Yes, the chapter warning is exactly that once the API layer becomes a mediator or orchestrator with business logic, you'll drift toward orchestration-driven SOA. Tighten the warning. It is not merely because the API layer is processing. The real architecture is validation is domain logic move out of bound to it. Ano yun? Yung nakalimutan ko. The definition of term. Bounded context. So it becomes closer to orchestration SOA because the API layer is now acting as a central mediator, which violates the microservices principle that interesting business logic should live inside each bounded context. That is the core operation issue. Add the deeper problem. The issue is not only different tools, it's also inconsistent operation behavior, duplicate implementation effort, no unified control plane, slow architecture-wide upgrades, storage. Stronger answer. At scale, embedding operational concern inside each service creates inconsistency and duplicate effort. Every team must independently implement, maintain, and upgrade the same capabilities, which turns operation into a coordination problem. There's also working service to service. Correct. Ang tabi kong correct ah. Reasons such as part is one is allowed and one is not. The reason is shared logging does not redefine domain boundaries. Ito pala yung maganda nga. Shared database does couple implementation and data ownership. Shared logging is acceptable because it's an operational concern and does not violate bounded context ownership. A shared database is different because it couples services at the data model level, undermining autonomy, deployability, and parang di ko yata kaya magsamagot ng ganitong kalalim. Pero kasi ganito talaga dapat yung mga interview style na answering. Send the next pages. So front end. Stop at choreography and orchestration. I think yan. Stop. Oh no. Okay. Okay. So baka front end, choreography, communication. Feeling ko maikli lang siya. Pero okay. So I was stop at this sa topic ng choreography. Tapos pagka-may time pa, I'll proceed to transactions and sagas. Ipapapars ka man ako sa GPT. That's why I'm taking pictures. Okay. Okay, last 2 pages. estimate ko yung number of, yung estimation ako. I thought mahihirapan ako sa mga H pages. Okay. Try tayo sa front ends. So let's wait while ChatGPT. Microservices favors decoupling, which ideally encompasses user interfaces with backend concerns. In fact, the original vision for microservices included the use interface as part of the bounded context useful to the principle in MDD, domain-driven design. However, practicalities of the partitioning required by web applications and other external constraints make that goal difficult. Thus, two styles of user interface commonly appear for microservices architectures. The first appears in Figure 17-5. So, API layer. So, parang ito yung tinatawag natin API gateway most of the time. It connects to each services. In Figure 17-5, the monolith front-end features a single user interface that goes through the API layer to satisfy user requests. Monolith nga siya. Tama pa ng monolith. It could be reached at desktop, mobile, or web application. For example, many web application uses JavaScript, a framework to build single user interface. Second option for user interface uses micro frontends. Actually, ito yung gusto ko matutunan, micro frontends. So, aso hindi ko siya mabigyan ng time. Parang ano siya, parang mukha lang siya, multiple front-end apps siya, pero when it faces the user, parang isang front-end application lang siya. Tapos nag-switch lang siya ng mga front-end UIs. In Figure 17-60's approach utilizes components at the user interface level to create a synchronous level of granularity and isolation in the user interface as the back-end services. Service emits the user interface for that service, which the front-end coordinates with the other emitted user interface components. Using this pattern, teams can isolate service boundary from the user interface to the backend services, unifying the entire domain within a single team. Developers can implement a micro front-end pattern in a variety of ways, either using component-based web frameworks such as React or using one of several open-source frameworks that supports this pattern. Services, architects and developers struggle with approach granularity, which affects both data isolation and communication. Finding the correct communication style helps teams services decouple yet still coordinate in useful ways. Fundamentally, architects must decide on synchronous or asynchronous communication. Synchronous communication requires the caller to wait for a response from the calling. And microservices architectures typically utilize protocol over heterogeneous interoperability. Protocol aware heterogeneous interoperability. Protocol aware because microservices usually don't include a centralized integration hub to avoid operational coupling. Each service should know how to call other services. Thus, architects commonly standardize on how a certain level of rest, message queues, and so on. That means the service must know or discover which protocol to call other service. Heterogeneous because microservices is a distributed architecture. Each service may be written in a different technology stack. Heterogeneous suggests that microservices fully supports polyglot environment where different services use different platforms. Interoperability described service calling on one another. What architects in microservices try to discourage transaction methods called services commonly call others as via network to collaborate and send receive information. Polyglot environment. What is polyglot environment? services are built using different technologies, language frameworks, database chosen based on what best fits each service needs. Okay. Gets. A well-known architect who was a pioneer in the microservices style was the chief architect of the Personal Information Manager startup for mobile devices. Because they had a fast-moving problem domain, the architect wanted to ensure that none of the development teams had accidentally create conflict points between each other, hindering the team's ability to move independently. It turned out that this architect had a wide mix of technical skills on the team, thus mandating that each development uses a different technology stack. If one team was using Java and the other was using .NET, it was impossible to accidentally share classes. This approach is the polar opposite of most enterprise governance policy, which consists of standardizing single technology stack. The goal on the microservices world isn't to create the most complex ecosystem possible, but rather to choose the correct skill technology for the narrow scope of the problem. Not every service needs an industrial strength relational database, and forcing it on small teams slows them rather than delegating them. This concept leverages the highly decoupled nature of microservices. Okay, for asynchronous communication, architects often use events and messages, thus internally utilizing an event-driven architecture covered in Chapter 14. The broker mediator patterns manifest in microservices choreography and orchestration. Ito na. So, mag-explain na further mo yung choreography and orchestration. Pero what I understand is in this one, choreography meaning services can parang each services can do its own business logic. So pwede silang they can work in parallel. My orchestration, it's like a workflow based processing siya. Tama ako. Choreography utilizes the same communication style as the broker event-driven. In other words, no central coordinator exists in the architecture, respecting the bounded context philosophy. Domain architecture isomorphism is one key characteristic that architects should look for when assessing how appropriate an architecture style is for a particular problem. This tends to describe how the shape of an architecture moves to a particular architecture style. For example, in Figure 8-7, the silicon sandwich technically partitioned architecture structurally supports customizability, and the microkernel architecture that offers the same general structure. Therefore, problems that require a high degree of customization becomes easier to implement in a microkernel. Similarly, because the architect goal is in a microservice architecture favors decoupling the shape of microservices and the broker EDA, making these two patterns symbiotic. Oof. So parang service to service yung ano niya. So meaning, kung sa choreography communication, dito mas maganda yung service mesh. In Figure 17-7, the user request details about user wish list because the customer wish list service doesn't contain all the necessary information. It makes a call to customer demographics to retrieve the missing information, returning the result to the user. Because microservice architecture don't include the global mediator like other service-oriented architecture, if an architect needs to coordinate several services, they can create their own localized mediator as shown in 7-8. Paano may common service, no? Using maging orchestration. So meaning, ito pagka ganito na yung ginawa, may orchestration na siya nangyayari. Masabay kasi pagka kinuha may customer wishlist, punta ulit siya sa service na yan to retrieve yung parang another layer siya. In 17-8, the developer create a service whose solely responsibility is coordinating the call to get all information for a particular customer. The user calls the report customer information mediator which calls the necessary other services. So most likely, temporal coupling na to. Ganun. Ayan. I-click ko lang. So tomorrow, mamaya pa lang gabi kasi 21 na pala. Patapusin ko na yung chapter na. Then chapter 18. Mukhang sa weekends mag-exam ako na ChatGPT exam. ChatGPT style exam. Matutulog na ako. Bago ko magpasit sa part 3. Bayusop, hindi kita malagay. First law of software architecture suggests that neither of these solutions is perfect. Each has trade-offs. In choreography, the architect preserves the highly decoupled philosophy of the architecture style, thus reaping maximum benefits touted by the style. However, common problems like error handling and coordination become more complex in choreography environments. Consider an example with more complex workflow. Pay for order. So, kukuha siya sa payment and then mag-replace si payment and then kukuha naman siya kay update inventory. So, it's talking to two services. So, yung communication niya is dalawa. And so, tingin ko sa ito yung possible na problem sa choreography. Unlike sa orchestration, I will just create an interface which is another service that will do the aggregation of data. Or parang routing siya. So, in figure 17-9, the first service called must coordinate across a wide variety of other services, typically acting as a mediator in addition to its own other domain responsibilities. This pattern is called front controller pattern, where a nominally choreographed service becomes a more complex mediator for some problem. The downside to this pattern is added complexity in the service. And actually, that's true. So, ito yung kanina. So, magkakaroon ng another layer. Ito ginagawa rin naman to sa mga sa clean coding. Pero this one is not really for coding, it's more of architecture siya. Pero yung principle niya parehas. Alternatively, an architect may choose to use orchestration for complex business process illustrated in 17-10. So isa na lang yung kinakausap niya. In figure 7-10, the architect builds a mediator to handle complexity and coordination required for business workflow. Yun nga lang, dependent na siya dito sa service na to. This creates coupling between these services. It allows the architect to focus on coordination into a single service, thus leaving the other less affected. What the heck? Often domain workflows are inherently coupled. The architect's challenge is finding the best way to represent that coupling in ways that support both domain architecture. So trade-off lang talaga siya, no? It's all about trade-off talaga siya. Walang tamang sagot. It's either you choose choreography, but you will have to but ang responsibility for the aggregation will be handled by that service. And then medyo marami kang ko-connectan, pero you will not have another service. Hindi ka na magkakaroon nun. Tapos ito naman, placeholder, pero ito mas less yung coupling niya dito. Tapos dito sa placeholder, mag-introduce ka ng service, so another service to handle siya. May deploy ka na namang isa, and then naka-couple na siya dito. So placeholder needs to have also order placement service needs to also have placeholder be deployed every time na mag-deploy siya, or else di niya mabubuo yung data, and also di niya mabubuo yung parang full full process business logic niya. Okay, anong book to? Ayun, nasa screen na siya, sa Fundamentals of Software Architecture. So ito yung cover niya. Is this an parrot ba to? Hindi ko lang kung parrot siya. Ito. Although may mga na siya, may makikita kang mga PDF sa GitHub, pero kung you will resort to getting free downloadable version niya. Pero kasi medyo mag-ingat lang kayo sa pag-download ng PDF ngayon. Let's say sa GitHub, may nakita kayo na ganito, PDF siya na Fundamentals of Architecture. Ingat lang kayo kasi minsan nag-embed sila ng mga malware dun sa PDF. So baka pag-open nyo, nagtanim na sila ng malware sa PC nyo. So that's why I opt to it's either I'm going to go to the o yung mga official book, let's say O'Reilly, Manning, doon ako bumibili ng e-books, or kung gusto nyo e-books na, pero tapos pag physical book, syempre let's say Amazon, Lazada. Pero kung medyo tight yung budget, kahit ang possible na magiging choice nyo is yung mga yung mga pirated. Ingat lang kayo sa pag-download ng mga PDF. Lalo ngayon na tayo, nasa era na tayo ng AI, wherein kaya na mag-write ng mga other developers ng mga parang malware scripts, and then mas mas creative na sila ngayon. So yeah, pero aside from that, ayan, ito siya. So Fundamentals of Software Architecture. Actually, maganda din siyang supplementary knowledge for developers. Hindi naman siya sobrang mahirap. Pinapahirapan lang talaga ako ng ChatGPT. Pero maganda sa part ng book na to is mas madali yung thinking process mo. And then usually kasi pagka when you're going to do an application, tapos ang laging ginagawa natin is yung pinaka-perfect solution. Pero dito is more on balancing what is the best parang best possible solution yung ituro niya dito. So yan, kaya maganda din tong kahit nasa beginner developer ka, pwede pa rin tong book na to. Actually pang nga to basta kahit na konti lang developer knowledge mo, pa rin to, okay pa din to. Ilang oras na ba ako? Mag-isang oras na ako ulit. So another kasi baka mag-over anyways, magbabasa pa ako ng summary niya ChatGPT. So mukhang mamayang gabi na ako. Itong last part, last pages, 3 pages will be tonight na siya. Tapos more on drill question, the usual drill question for every chapter. And then chapter 18, I can finish this until kaya naman to. Mahaba din pala siya. And 10 pages lang siya. Oh, okay pala. Abot ba ng magnet yung ano? I-scan ko lang. The front end is often still a monolith. Simple deployment. You may have clean backend boundaries but tightly coupled front end. That is partial failure of microservice philosophy. Medyo mahirap din kasi mag-implement ng micro front ends. Medyo complex din siya. Micro front ends fix backend coupling but introduce front end orchestration at tama. Communication the real core problem. Fundamental decision. Synchronous versus asynchronous. Synchronous. Ito yung usually na ginagamit natin. Temporal coupling, latency, cascading. Pero diba synchronous pala ang gRPC because hindi ko masyadong ginagamit to. Ito events messaging. Usually WebSocket is asynchronous. Here, communication style determines system coupling more than service boundaries. Protocol overhead. Each service must know how to call others or discover how to. Heterogeneous, each services can use different language, DB, different runtime. Microservices allow polyglot architecture, meaning it can be it can be different tech stack. That depends. Basta magawa niya yung goal ng service na yan. But introduces interoperability, complexity, protocol, negotiation. I think ito yung naging ito yung problem namin sa workflow platform. So, the one is written in Go, and then the one is written in Rust. So, interoperability, complexity nga. So, pero ang common namin is, we're using events to communicate between applications. And for heterogeneity, What architect did force teams to use different tech stack. Why? To prevent accidental coupling by a shared code. Brutal but effective principle. If teams cannot share code, they cannot accidentally couple. Tama naman to. Kaya hindi kami makapag-share ng code nung kasama ko. Fragmentation, skill overhead, harder hiring maintenance. Kaya ito medyo mahirap kasi ako lang yung nag-rust. Most companies do the opposite. Standardize everything. Microservices require controlled divergence. Divergence meaning? Services. What does means allowing services to differ in technology design or implementation, but within the constraints, so system remains manageable. Everyone does anything, everyone uses the same exam stack. Correcting teams can diverge but within guardrails. Okay. So inconsistent APIs. Standardized REST, RPC standard also. Yeah, okay. So far, we're following this naman. Okay. Choreography versus orchestration. Central coordinator, service call each other direct or react events. Wishlist, call customers, demographics, benefits, high decoupling, central bottleneck. because coordination is implicit, hard to trace flows, error handling is complex. Key insights: choreography, decentralized control, orchestration, service acts as a coordinator, mediator, handles workflow, customer info service, wishlist, demographics, benefits, centralized workflow, control, user reasoning, simple coordination, cost, introduce coupling, become mini SOA risk. Yeah, this one. Importance, nuance. This is not chapter 16. So, orchestration is localized, not enterprise-wide. Localized in the sense of parang yung mediator is catered to that parang specific specific services lang siya. Choreography for complex workflow, order payment. Even in choreography, coordination does not disappear, it just moves somewhere else. Ito yung mga trade-offs niya. High decoupling, harder to debug. Implicit flow, complex error handling, simple recovery, explicit flow, easier to reason, centralized control. The most important lesson in this section: there's no pure solution. Neither solution is perfect. Tama. Always trade-offs. So pipili ka na lang kung what it will be your selected trade-off. Architect level na simple. Use choreography. If you force choreography on complex flows, chaos, orchestration everywhere, so what regression. Okay, front end trap. You have microservices backend. So scan ko lang to. Mas maganda. I will try answering this one on my next study session. Tapos mag-quick LLM lang ako. Gusto ko lang i-check yung mga concept part ng LLM. You can micro-front and improve backend but UI less. 5 questions na naman siya. Okay. But anyways, so medyo mag-iba tayo na gagawin. Close ko muna ito. Meron ba akong notebook LM dito? Ito. Building LLM from scratch. Search lang tayo ng libro. Wala siyang HTTP. Libre lang pala siya. At libre lang pala to. Binili ko pa siya for 4K pesos. Nagsayang ako ng pera. Anyways, come on, tingin. Parang na-down ako doon. Ano ba sa iOS nito? Notebook FM na to. Meron siyang app. Wait, is this Google? Google na siya. Oh no, I forgot na. Try ko tong ano to. Notebook LM na to. I would be happy self-study based on the perspective. Okay. Ang galing naman ito. Why to customer? Okay. Pero yun na yun. So parang pinaikli niya yung learning ko. Maganda to. Tignan natin to. Yung classic. Tapos gagawin yung video, no? Explainer. I wanna check this one. Pag ito maganda yung output niya, ito na gagamitin ko. Hindi, wala pa ako sa ganun level. Nagta-transition pa lang ako from developer. Tinatry ko pala, hindi pala transition, more of ina-upskill ko yung sarili ko to be more on architecting. Matagal din pala siya, no, pag mag-generate ng video. Okay, pero mukhang maganda to, ano. Kano kaya katagal to? Gusto ko makita yung video overview niya. While I'm waiting, basahin ko lang siya. Hindi na to sa architecting. Nagkano lang ako. Sneak peek lang ako dito sa konting basa lang dito sa building LLM from scratch. Medyo na-excite ako dun sa mga gagawin. Maganda yung mga topics niya. So, tatry ko lang tanggalin yung mga concepts na pages. Okay, meron siya, oh.
Welcome to today's deep dive. So, I want you to imagine you walk into this massive library, but the librarian doesn't actually know how to read.
That sounds incredibly frustrating.
Right, like you ask for a book on French cooking and they hand you a French dictionary, a history of the French Revolution, and maybe, I don't know, a novel with a character named French.
Yeah, because they're just matching the shape of the letters on the cover. I mean, it's highly inefficient.
French dictionary, a history of the French Revolution, and
recognizing a
maybe,
visual
I don't know,
pattern
a
is
novel
the same
with a
as
character
actually
named French.
understanding. Yeah, because they're just
Exactly, and that illiterate librarian
Hindi
would
pala yun yung
basically the absolute ceiling of natural language processing for
Delete
decades.
natin. baka matagal yung video. Subset of machine learning and artificial intelligence focus on neural networks. LLMs are trained on vast quantities of text data. This is large-scale training allows LLMs to capture deeper context for information and subtleties of human language compared to previous approaches. As a result, LLMs have significantly improved performance with a wide range of NLP tasks, including text translation, sentence analysis, question answering, and many more. Another important distinction between contemporary LLM and early NLP models is that earlier NLP models were typically designed for specific tasks such as text categorization, language translation, etc. While those earlier NLP models excel in their narrow application, LLMs demonstrate a broader proficiency across a wide range of NLP tasks. The success of LLM can be attributed to the transformer architecture that underpins many LLMs and vast amount of data on which LLMs are trained, allowing them to capture a wide variety of linguistic nuances, context, and patterns that would be challenging to encode manually. This shifts toward implementing models based on transformer architecture and using large training data set to train LLMs has fundamentally transformed NLP, providing more capable tools for understanding interacting with human language. The following discussion sets a foundation to accomplish the primary objective of this book. Understanding LLMs by implementing a ChatGPT-like LLM based on the transformer architecture step by step in code. Tagal naman ng video, tapos ko nang basahin yung mga pages, hindi pa rin tapos. What is an LLM? LLM is a neural network designed to understand, generate, and respond to human-like text. These models are deep neural networks trained on massive amount of text, sometimes encompassing larger portions of the entire publicly available text on the internet. The large language model refers to both the model size in terms of parameters and immense data set on which its trained models like this often have tens or even hundreds of billions of parameters, which are adjustable weights in the network that are optimized during training to predict the next word in sequence. Next word prediction is sensible because it harnesses the inherent sequential nature of language to train models understanding context. Structure and relationship within text is very simple task, and so it's surprising to many researchers that it can produce such capable models. In later chapters, we will discuss and implement the next word training procedure step by step. So mukhang sasabak na agad Tagal naman ng video na to. Paano nilagay ng cover yan? Galing, guys. Pwede pala yun. Galing. Mas okay to Parang super catered for learning talaga siya. Kaya natin has an experience in programming with it. ko gusto yung ganitong way of ano.
So we've all had that
Interesting.
moment, right?
Ah.
So we've all had that moment, right? You type something into a tool like ChatGPT, and wow, the answer it gives you feels so human. But how in the world does it actually do that?
Ang galing naman
Well,
ito.
it's not magic. Today, we're going to pull back the curtain and really get into the technology behind these things called large language models. Let's figure out how the trick is done. Okay, so look at this. You can just type in something completely random, like write a 4-line poem with the words Wisconsin, AI, and pizza. And just seconds later, boom, you get a poem that actually makes sense. It really does feel like pulling a rabbit out of a hat. But like any good magic trick, there's a method behind it, and we're about to break that method down layer by layer. To really understand what an LLM is, you can't just look at it in isolation. You kind of have to see where it comes from, right? It's part of this bigger family tree of technology. It didn't just pop into existence, it's got a whole history. And this right here, this is our map. Think of it like one of those Russian nesting dolls. We're gonna start with the biggest, outermost layer, and then peel back each one until we get right to the center, right to the LLM itself. So that biggest circle, that's artificial intelligence, AI. This is the granddaddy of all. It's the huge umbrella term for any system that can do something we consider, well, intelligent, human-like. It could be as simple as an old chess computer, or as complex as the software on your phone that tags your friends and photos. Okay, so let's pop open that first layer. Inside, we find machine learning, and this is where things get really cool. See, instead of a person sitting down and coding every single possible rule, if this, then that, the computer kind of figures it out on its own. It just learns from examples. Think about your email spam filter. Nobody told it if an email mentions a foreign prince, it's spam. Nope. It just saw millions of spam emails and learned to spot the patterns by itself. All right, let's go one layer deeper. Now we're at
Ang galing nito yung Google
Think of this
Notebook
as
LM.
machine learning on steroids. It uses something called a neural this sort of
Translate
model
mo into video yung
it has all
pages.
these layers, and that's why they call it deep. All those layers let it spot patterns that are way too complex or subtle for anything else to see. And here we are, at the very heart of it all, the center of our map. This is the large language model, the LLM. It's a very
Gusto mo itong mag-code ba dapat na yung pag-aralan? Then, actually, mas maganda alamin mo muna kung anong classic applications that you wanted to develop. Are you going to develop a game? Are you going to develop a website? Are you into something like na nagagawa ng mga parang features sa mga OS or something like that? After mo ma-figure out yun, doon ka mag-check kung ano yung mga possible languages na pwede mong aralin. But always, pagka mag-aaral ka ng mga programming languages, always start with the foundation. So, which is usually the basic way of understanding. Yung mga basic topics. So, yun. Yun yung guidelines mo. I cannot tell you what will be the language. Kasi depende yan sa interest mo.
specific, very powerful type of deep learning. It uses those same complex, deep neural networks, but it's been trained for one job and one job only, to master human language. Okay, so we know where it fits in the family. Now let's look at the name itself, large language model. It sounds a bit technical, but it actually tells you pretty much everything you need to know. Let's just break it down. First up, large. And they're not kidding. This refers to two things. One, the model itself is huge, with billions of what they call parameters. You can think of them as little dials and knobs that it adjusts as it learns. And two, the amount of data it learns from is just astronomical. We're talking a huge chunk of the entire internet. Now for the second part, language model. This is what it does. And its main job, believe it or not, is shockingly simple. It's designed to do one thing: predict the next word in a sequence. That's it. It sounds almost too simple, but getting really, really good at that one task is what unlocks everything else. So really, if you're going to take away one thing, let it be this. At its very core, an LLM is just a super powerful what word comes next machine. That's the secret. By mastering that one simple sounding skill, it learns to write poems, summarize articles, translate languages, all the incredible stuff we're seeing it do. And that ability, the ability to actually generate new coherent sentences, that's the real game changer here. It's what separates these new models from everything that came before. It's not just an improvement, it's a whole different league. So if you look at the old way versus the new way, the older tech, which we called natural language processing, or NLP, was really good at sorting things into boxes. It could read a movie review and tell you, yep, that's a positive one, or nope, that's negative. But it couldn't write a review from scratch. LLMs, though, they're not just sorters, they're authors. They can understand nuance and create something totally new. This quote really just says it all, doesn't it? Previous generations could not write an email from a list of keywords. Think about that. Something as simple as turning a few bullet points into an email was basically impossible for older models. But for an LLM today, that's, as the quote says, trivial. It's a warm-up exercise. That's the leap we're talking about. Okay, so these things are obviously incredible, and powerful tools like ChatGPT are available to pretty much everyone, which brings up a really good question. Yeah, why would you bother? If these giant, super smart models already exist, why would anyone go through all the cost and effort to build their own? Well, it turns out there are some really solid reasons. For one, if you build it, you actually understand how it works, warts and all. You can also train it to be a specialist, an absolute expert in one narrow field, like legal contracts or medical diagnoses. And here's a big one: privacy. If your data is sensitive, you probably don't want to be sending it off to some other company's servers. And finally, you can build smaller, more efficient models that can run right on your laptop or even your phone, no internet required. So it doesn't really matter if it's one of the giant public models or a tiny custom-built one. The bottom line is, these things are everywhere now. And they're not just a new feature, they are completely changing the way we use technology. And I mean, this isn't some far-off future stuff. It's happening right now. They're the brains behind the chatbots you talk to. They're showing up in your search results on Google and Bing. They're doing instant translation. They're writing code. They're writing marketing copy. They're even reading all your customer feedback and telling companies if you're happy or mad. It's like we're adding a new layer on top of the entire internet, a just talk to. And that's really the big picture here. This quote nails it. We're slowly moving away from a world of clicking on icons and navigating complicated menus. Instead, we're moving towards a world where getting things done on a computer is as simple as, well, having a conversation. It's making technology more intuitive and, honestly, more human. So yeah, this isn't science fiction anymore. It's here, it's real, and it's already changing things in ways we're just beginning to understand. So the real question for all of us isn't, is this going to have an impact? It's, what kind of future are we going to build with it?
Wow. Interesting tong ano ta. So, 1, 2, 3, 4, 5. So, I started with this. 1, 2, 3, 4, 5. So, this one is the last one. Yeah. So, that video explained the 5 pages in 5 minutes. Though it took a while for it to generate the video. Let's put some. Babasahin ko pa rin yung pages na mo kasi mukhang may mga in-skip yung video. Okay. After nito software fundamentals. Tama na. Tama na. Kaya lang. Unti-untiin ko lang tanggalin yung mga parang introduction para pa nandito na ako sa LLM. Ano na ako, more on implementation na lang. Okay, so it's already